Hello friends, welcome to our YouTube channel. So the problem that we are going to discuss today is Leetcode 475, that is heaters. In this problem, you are given the positions of some houses and heaters, and they are told that they are on the horizontal line. So you can assume that they are on x-axis, their positions are given, and you need to return the minimum radius standard of the heater so that those heaters could cover all the houses. And there is a note that is given that all the heaters follow your radius standard and the warm radius will be the same. Okay, let's look at the problem with examples. So take the first example, that is, for example, you have a straight line, right? So this, assume this is the x-axis. Okay, and we have, say, these are the positions of the houses. For example, one is at position 5, another is at position 25. Okay, now, for example, there is a hitter at this position and there is a hitter at this position. Okay, say assume this position is, say, 3 and this position is, say, 30, right? Now, if you see, right, if this hitter can cover this house in, say, 5 minus 3, 2 radius, right? So 2 units of radius can be enough to cover this house, right? If it wants to cover this house, it should need kind of 7 for this house. Okay, for this it needs, say, 12. For this it needs, say, 22, right? Similarly, for this it needs, if this heater wants to cover this house at 25, so this needs, say, 5 units of radius. Similarly, if this hitter at 30 wants to cover the house at 15, it needs kind of a 15 radius, right? Similarly, for this, it needs 20. For this, it needs, say, 30 minus 5, 25, right? But I mean, you can see, right? This house can be covered by this hitter easily with radius 2, right? And we don't need that. I mean, this heater at the end should cover this first house, right? At 5, because it needs kind of 25 radius. So that is huge, correct? So now how you will decide that, I mean, what should be the minimum radius? Okay. So you'll compare each house with all the hitters, right? Think, for example, this is the first approach that I'm thinking. First, for example, we have a house at 5, compare it with, say, this hitter 1. Okay. How much radius it needs? It needs 2, right? So let's say we are comparing it for H1, that is house number 1. This is, say, this is H1, this is H2, this is H3, this is H4. Okay. Now for house number 1, I mean, heater number 1 needs, house number 1, first heater needs 2 radius, second heater needs kind of 30 minus 5 is 25. 25. What is the minimum? 2, right? Similarly for house 2, first hitter needs 7, right? 10 minus 3, 7, correct? Second hitter, if he wants to hit up H2, it needs kind of 20 radius, right? So the minimum would be 7, right? Now for H3, for house 3, first hitter, say, it needs kind of 12 units of radius to hit up H3. Similarly, the last, which is at 30th position, this heater requires, say, 15th unit of radius to cover H3, right? So what is the minimum that is required for H3? 12, right? Similarly for H4, right? For like for 25th one, so this H4 needs, so that will be 22, right? 25 minus 3. Again, for this is 30 minus 25, that is 5, correct? Minimum is 5. So these are the minimum radiuses, I mean, which are required to heat up each one. So what is the standard radius that I can order for any of the heaters will be 12, right? Maximum of those. So in this case, my answer is 12. So let's make it more complex, right? So assume there is one more heater at this position, which is say 12. Okay, so this is the 12th position at which another heater is say situated. Now you see, right, there is no point for this H1. We should, I mean, if 12 needs to cover this H1, in how much radius it can cover it? 7, right? 12 minus 5, 7. And if this 30th, if the heater at 30th position needs to cover this house at H1, that needs say 25, right? 30 minus 5, that is 25. So, I mean, there is no point kind of looking for the house which is further than your just left or just right, right? You need to only look for house heaters which are just to your left and just to your right. No need to look for the heaters which are further than your left ones and right ones, right? Just left and just right. Because see, this is the right to this H1, right? So let me draw it clearly here. So for example, this is the line. Say this is the heater position. These are the two heaters and this is the house, right? And say this is another heater. This is another heater. Now for this house, when I'm looking for this house, right, I should only check for the left and just right, right? Because if I go further right to this, so the radius will be increasing, right? Because they are on x-axis itself. So I need not check the, I need to only check the just right to it and just left to it. There is no point checking if there are further other hitters here. There is no point checking these, right? There is no point checking these. Just for this house, I need to check only this and this. I hope this is clear. So for every house, I should check the left hitter, compare the radius, or maybe jot down the radius, go to the right hitter, compare the radius, get the minimum of these. Now for each house, I have the minimum, right? I mean, for example, there are 4 houses given. So I have 4 minimums route. Now I need to take the max of those, like here, right? I have the kind of 2, 7, 12, and 5. These are 4 minimums. Now I need to take the max. 12 is the answer, right? So the approach should be, I'll see for each house, I'll look at the heater at just left of the house and look at if any heater is placed at the right of the house, just right to it. Okay. Now I'll compare the distances. I'll took the minimum one. Now for each house, I have these distances, right? These are the kind of minimum for each house. Now I'll kind of take the max of those. I hope the approach is clear. Now let's code it, right? So mm, for example, I'm writing here, I'm going to each house, right? Now for each house, I want to find just left hitter, right? And we'll pass the hitters array, say. Similarly, I want kind of find just a right hitter. Okay. let's assume, I mean, it is returning me the index of the left and the right heater, just left to it and just right to it. So left heater and right heater. Okay. Now what I'll do is, let me, yeah. So somehow these two methods are giving me for this house, what is the just left heater to it? What is the just right heater to it? Now I'll compare the, now if say left heater is null, not null basically. Now say, now I'll compare the left distance. In the starting, I'll say integer dot max value. Okay. If it is not equal to null, then I'll say, because it's a left to it, right? So I'll say left test equal to my house is at the right, correct? Because I'm finding a heater at the left. So it will be, say, heaters of left heater, right? Mhm. Now, similarly, I'll do it for right distance. So my right distance is here. If my right heater is not equal to null, I'll say right is equal to, this is the right heater, right? Now, for now I keep on kind of taking the minimum of it, and I also maintain a max, and I'll maintain, say, math dot minimum of left and right. So this will be the minimum for each house, right? And I need to take the max of all those, right? This is what we need to do, right? Now let's see how we are going to implement this find just left hitter and find just right hitter. If you see, right, I mean, hitter is already sorted. I need not sort it, but let's see, because I'm familiar with kind of the tree map or tree set APIs. So since it's a sorted collection, so I'll take a tree set of integers. Okay. And I'll say for int maybe k iterators ts dot add say k. So I've added all the kind of header uh, elements into it, and now I'll say I need a value from these heaters which is just lesser than this house position, right? Just lesser than or equal to. Okay. Then I'll look for floor key, or maybe floor. Yeah. And here I will look for ceiling, right? So I'll say ts dot floor, ts dot ceiling. Okay. And I'll pass on this house, and it'll give me kind of the integer. Okay. Now this is giving me the exact integer. So I just need to subtract that. I need not go to the header array again. Okay. I need to kind of subtract that. Now I'll get, so this floor is giving me the a key, or maybe a value which is lesser than this position. House is I lesser than or equal to. This is greater than, just greater than or equal to. Okay. So as let me explain it here if you want me to. Yeah. Just a minute. So for example, this is the, just a minute. This is the line, right? And now I have, say, here is the house, here's another, here's one house, correct? Now I have kind of heater positioned at multiple places. Okay. But for this house, I need a heater which is just left to it, or maybe on it, just right to it, or maybe just on it. So this is called basically the floor, and this is called the ceiling. So from the set, which is a sorted set of these heaters, I'm finding a value which is just lesser than or equal to this, or just greater than or equal to this. So that's how I'll find these values and I'll compute the distances now. I hope this is clear. Let's jump on to that. And now I'll return max, right? So I've created a tree set. I've added all the heaters values here, take a max value, iterate it over the houses, check the floor and the ceiling for this houses. This is the left heater, this is the right heater. If this is null, say there is no left heater available, so I'll take it as a max value. But if the heater is available, I'll subtract it from there. Now, okay, this should be right heater minus house I, because otherwise it will be negative, right? Now let's run it. Okay, I is less than equal to. Mm-hmm. Okay, it is ceiling. Sorry again. Okay, submit it. Yeah, it got submitted. Just one improvement that you can do here is I took a tree set to sort these heaters, but it is already sorted, right? So you can use arrays.binary search as well. So that will kind of improve the complexity because I'm kind of sorting it again, which is already sorted, right? So yeah, hope you liked the video. Please like, subscribe, and share. Thanks a lot.